Hi, and welcome to the guided practice for our classifying rational numbers. So we're asked to apply the names to these each number here. So we have a fraction, 7/8. I'll zoom in more. 7/8 looks to be a fraction of integers, and if I use my handy chart from the lesson on 14.2, and if we have 7/8, we can see here that 7/8 would be somewhere in this area. We have fractions of integers, so 7/8 would be here, so that's a rational number. If it's rational, then it's also real. So we have this, and that's why right here we have rational and real. Okay, square root of 36. So for the square root of 36, number 2, we have to think about, well, where will it go? And the square root of 36, that looks like it would go something like this. The square root of 36 is equal to 6, which is a whole number. And if it's a whole number, then it's also an integer, and it's also a rational number. So we come over here, and that's why it's going to offer us several things here. It's a whole number, it's an integer, it's a rational number, and it's a real number. And the square root of 24. The square root of 24, let's see, I don't know what the square root of 24 is. That's over here. That's irrational, and if it's irrational, then it's also a real number. And that is right here, irrational and real. Number 4, 0.75. Let's see what we got here. 0.75. Well, 0.75 is a terminating decimal, so 0.75, that is 75 over 100. There's a rational number. It's rational and real. So this is definitely rational and real. Number 5, 0. Well, where do you think 0 would fall into this? Well, 0 right here is a whole number. It's right there. So that means it's a whole number, integer, rational, and real. It's everything. And that's what we have right here. So the opposite of the square root of 100. So the square root of 100, so if the square root of 100 is right here, this negative of the square root of 100, or the opposite of that, would be right there. So it's an integer, actually. It says it's negative 10. Integer, rational, real. And that's why we would have this here. And this one right here, number 7, 5.45454545, that can be written as 5 and 45 over 99. And there's a rational number and real. And then this one, let's see, that's equal to negative 3, right? Which is an integer. And if it's an integer, then it's a rational and a real number. Okay. So now we have these, are they true or false? What are they? All whole numbers are rational numbers. Well, if we look at this here, all whole numbers are rational numbers. So the whole numbers are inside of the rational numbers, so that is definitely true. So, yeah, that's definitely true. And so, true, the whole numbers are a subset of the rational numbers. They're inside the rational numbers. And they can be written as a ratio, of a whole number to 1. So, for example, what they're talking about is, since we have the number 7, that's a whole number, and it can be written as a ratio of integers, 7 over 1, over the whole number to 1. So the next one, no irrational numbers are whole numbers. Well, that is true as well. Whole numbers are rational numbers. They are not irrational numbers. And Identify the set. Let's see here, make it a little bit smaller. So identify the set that describes each situation, the change in value of an account when given to the nearest dollar. Well, let's see, you can get, that's a terminating decimal because it goes to the hundredths, right? Because 100 pennies to a dollar. And that sounds, that would be a rational number. Oh, integers. Oh, to the nearest dollar. Oh yeah, to the nearest dollar, not pennies. So the nearest dollar, that's whole numbers right there. So that would be integers. Change can be a whole number amount, and it can be positive, negative, or zero. Yeah, negative, because you would owe money if it were negative. And how about the markings on a standard ruler? 1/16th, that looks like right there, that's a rational number. And rational numbers. The ruler is marked every 1/16th of an inch. Okay. And then we have number 13. What are some ways to describe relationships between sets of numbers? Well, this is what we could have. We could describe one set as being a subset of another, or show the relationships in a Venn diagram, which is what this is. Oops. Let's see. This right here. This is a, where are you? That is a Venn diagram right there. So there you go. There's some number classifications for you. Thanks for watching.